2?
Yeah, the 2 in there, just ignore it.
You multiply it, yeah.
And you'll see, yeah. Ask yourself, where is sine equal to 1/2? Okay, so you look at the unit circle.
Oh. I got 2.
Where is sine equal to 1/2? Well, sine is going to be equal to 1/2 at pi over 6 and 5 pi over 6. Okay, so we write theta equals 5 pi over 6 plus 2 pi k, and we write theta equals 5 pi over 6, right? Yeah. Plus 2 pi k. Now, these are the solutions for sine of theta, not sine of 2 theta. So if we want to get sine of 2 theta, what we do is, instead of writing just theta here, we'll put a theta, we'll put the 2 there. Okay, basically whatever is here, you're going to put over here. Okay, whatever is here, you're going to put over here. That's the easiest way to do it, right? Ask yourself first, okay, where is sine of theta equal to 1/2 pi over 6, 5 pi over 6, add 2 pi k, 2 pi k. But remember, the argument here is 2 theta, not theta. So put 2 theta here instead of just theta. And then of course you have to solve for theta, right? So you divide everything by 2. And what ends up happening is, if you divide a fraction by a whole number, it's the same thing as multiplying its denominator by a whole number. So it becomes pi over 12 plus pi k, because 2's divide out. So this side, you get 5 pi over 12 plus pi k. Okay? Because what are you going to do when you get a solution out of here? You're going to multiply it by 2. And that's going to transform it back to this form, right? If you really think about this, pi over 12 times 2 is pi over 6, right? So you're basically saying, okay, every input I plug in, basically I'm going to multiply it by 2, and that has to become the original solution, right? If you really think about this, it actually makes a lot of sense. Okay. Now, they want all the solutions between 0 and 2 pi. So, there's usually this thing called the ceiling and the floor. The floor is basically, the idea behind it is like all the value of k where you don't get any solutions anymore. So watch this. If I let k equal -1, right, then this number is going to be negative because pi over 12 is 15 degrees and you're adding it to -180. So that answer is negative, right? And that's not between 0 and 2 pi. Okay. So the floor is probably k equals -1. Let's try k equals 0. Is that okay so far? You guys all right with this, what I'm doing here? You sure? You guys understand why I pick k equals -1?
No, wait, hold on.
Okay, I'm trying to find all the solutions between 0 and 2 pi. If I pick k equals, I can pick k equals -1,000,000, right? But I'm going to pick numbers that kind of make sense here. Basically, I need to pick k values that make this answer, whatever I plug in here, and once I add them together, whatever theta is, it has to be between 0 and 2 pi. The problem is that when k is equal to -1, the answer is already negative. Right? It's technically 15 degrees, I think, plus -180. So it's going to be a negative number, right? Which is not between 0 and 2 pi. If I let k equals 0, I just get pi over 12. Okay? So theta equals pi over 12. Well, that's between 0 and 2 pi, right? Okay. Same thing over here. If you let k equal -1, this is still the whole thing's gonna be negative, so it's not gonna work. So we try k equals 0, we get pi over 12. Over here we get 5 pi over 12. Okay. Ooh. So let's try k equals 1. Okay. Now we try k equals 1. See what happens. We get 15 degrees plus 180, which is 195, I think. 195 is between 0 and 360, yeah? So that works too. So we have to add this in radians though. So this is going to become 12 pi over 12, which is 13 pi over 12. We got to do the same thing here. This is going to become 12 pi over 12. So this is going to become 17 pi over 12. And again, these are between 0 and 2 pi. So, oops. So this works. Okay. Now let's try k equals 2. Now, if you try k equals 2, this is 2 pi. That's 360 already, right? And if you have 360 to 15, you're beyond this, right?
Mhm.
So k equals 2 is the ceiling,
Oh.
okay? And that's kind of like the idea here. So if you want to like organize this,
So this is
k
the
equals -1 is the floor. Okay? And k equals 3. So what that means is doesn't make sense to keep going, right? If you're gonna go k equals 3, well, you're beyond it, right? This is already, you're way beyond 0 to pi, okay? Because now you're talking about 3 pi, 4 pi, 5 pi. So you always have like this floor and ceiling thing you have to kind of find, right? If you don't find them, the biggest error you will make is that you will omit some of the solutions, right? Because you won't go either down far enough or up far enough, right? And you will miss some of the solutions, essentially. That's the danger that you have to watch out for, okay? Always find the floor and the ceiling, right? And you won't have that problem. So you can see here, they kind of do that. See here, they do k equals -1, and see they get -11 pi over 12. That's not between 0 and 2 pi. So they're gonna stop there. They're not gonna go k equals -2, for example, or 4. If k equals -1 doesn't work, then y equals -2. Then you try 0, those work, 1, those work, but 2, they don't work, right? Because these are too big. It's 2 pi plus something. That's already too big, okay? And how do you know where to stop and all that? It depends on this, what they ask for. Okay? They want all the solutions between 0 and 2 pi. These generate all of them, but they only want the solutions between here and here. So you use these to generate the solutions that make sense, that are somewhere around here. You don't want to pick k equals 10,000. That'd be pretty stupid, right? So that's kind of like the idea here. So that's what's going on. You can see here. That's how you kind of do it. Floor, ceiling. Okay, floor, ceiling. Always find the floor and ceiling, and you'll be all right. Okay, let's do another one. This time with tangent. Okay, tangent. Theta minus 5 and 12 equals 1. Okay, where is tangent equal to 1? Be careful with tangent. Tangent has a period of pi. You only step from 0 to pi. Okay. Where is tangent equal to 1 from 0 to pi? Anybody know?
Pi over 4.
Pi over 4. That's right. Pi over 4. So what do? We take whatever is in here. We set it equal to pi over 4. And then what do we add? Do we add 2 pi k? What do we add? What's the period of tangent? Pi.
Oh, whoa. Oh, yeah, just repeats itself.
Right? The tangent starts repeating itself after pi. So again, don't worry too much about this. This is what makes tangent of theta equal to 1. Don't forget to add pi k. Do not add 2 pi k, that is wrong. The period of tangent is just pi. Right? It starts repeating itself once you pass pi. Not like cosine and sine. Okay? And then you gotta solve for theta, right? So we kick the pi over 2 over. This we're not multiplying, this is just a number. We move it over. So pi over 2 plus pi over 4 plus pi k. Get the same denominator, we're gonna get 3 pi over 4, right? So you're gonna multiply this top pi by 2, and then you add 2 pi plus pi is 3 pi over 4 plus pi k. Okay, that's the solution. It's generating solution set, right? Now we'll generate all the solutions. Now we're gonna see what they asked us for. They asked us for all the solutions between 0 and 2 pi. So here we go again. We start with k equals -1. That's usually a good starting point. When k is equal to -1, this is -180, and this number is not bigger than 180. So this solution would be negative. So this is definitely the floor, hopefully. Sometimes 0 could be the floor. We'll see. If you put k equals 0 in here, we just get 3 pi over 4. That's not the floor. So in that case, this is the floor, right? Try k equals 1. 5 plus 3 pi over 4, that's less than 2 pi. That's going to be 5, 6, 7 pi over 4, right? You got to multiply this by 4 and add them. And then k equals 2. Well, it's kind of silly, isn't it? That's 2 pi plus something. That's bigger than 2 pi, right?
Mm-hmm.
So this is the ceiling. Okay, so the only solution are these. And that's it. They don't really use that language floor and ceiling, but I think you should try using it. It will help you keep this stuff straight. This is a calculator. We'll deal with this later. Talk about it later. I'll teach you how to use a calculator. Okay, now we got like a simple quadratic, right, in the form of a trig problem. Quadratic in the form of a trig problem. So what do we got here? We got 2 sine squared theta minus 3 sine theta and plus 1 equals 0. Now they don't do this here, but I highly recommend you do this. This will also help you in calculus later on. What you should do is do a variable transformation. And what that means is it's kind of like this. Let x equal sine theta. Okay? That means x is the same thing as sine theta, right? That's what we did by symbolism. We said x is the same thing as sine of theta. So wherever you see sine of theta, you can replace it with x, right? So this becomes, and that's a lot easier to work with, isn't it? You guys are very familiar with that. That's a simple trinomial. It's got a coefficient in front, so we gotta be a little bit careful when we factor this. Now some of you guys, I don't care how you factor it, just have technique. Okay, so 2 times 1 goes here, the negative 3 goes here. I need 2 numbers. When I multiply them, give me -2, give me +2. When I add them, give me -3. All right, -2 and -1. When I multiply, give me 2. When I add, 3. And then I do factor by grouping. That again, I don't really care how you do it. Some people divide and have a whole kind of system. I don't care as long as you don't factor this thing. Okay, so here I just write -2x, -1x. Yeah, split the middle term. -2x minus 1x. That's -3x. Okay, everything else is the same. Okay. And then I factor by grouping. I factor those two, and I factor those two. So this is called factor by grouping. Over here, we got to make this appear. So I'm going to factor out -1. Okay. -1 times x is negative x. -1 times -1 is positive 1. Okay, and then we look at this, right? We went from 4 terms to 2 terms. This is just 2 terms. Now we factor out what's common in both these terms. For instance, right, how do you factor this? You would just write 3 plus 5 times x, right? That's what's common in these 2 terms, yes? Okay, so it's the same thing here. What's common in both these terms is the x minus 1. So if you take that out, what you have left is this. And that's how you factor that, okay? Now, the problem didn't start with x. The problem started with sine theta. So we need to transform it back to sine theta. X is sine theta, right? So we come back to this problem, right? It's 2 sine theta minus 1 times sine theta minus 1. Okay, anytime you have 2 things being multiplied and it's equal to 0, 1 or both have to be 0. That's just the only way anything can be 0, right? So either this is 0 or this is 0. So we take this, set it equal to 0, take this, set it equal to 0. Then we solve for sine, right? We get 1/2. You know what we have to do there. Move the 1 over, and we have to solve for both of these now. Okay. So where is sine of theta equal to 1/2? Okay, we've kind of seen that already. It's equal to 1/2 at pi over 6 and pi over 6. Okay, so theta equals pi over 6 plus 2 pi k. Theta equals pi over 6 plus 2 pi k. Okay. And then over here, this is a quadrantal angle, right? This is not a quadrant, it's in between the quadrant, right? So this one doesn't, it's not gonna have 2, it's only gonna have 1. This is right here. It's pi over 2. That's the only place you get 1, right? So it's gonna be theta equals pi over 2 plus 2 pi k. Alright. And now we can start generating the solutions. So we're gonna start picking the k's and all that. But once you get pretty good at it, you can probably simplify a lot of that work. They want all the solutions between 0 and 2 pi. If you let k be negative, all these answers are going to be negative. If you let k be 0, well, then you get 3 solutions: pi over 6, pi over 6, and pi over 2. And then k is equal to 0. When k is equal to 1, this is 2 pi, 2 pi, 2 pi. Those are all too big already, right? You're adding, and you have to be between 0 and 2 pi. How is that possible? How can you be between 0 and 2 pi and be adding something to 2 pi already? So that's it. It's just the floor is -1, the ceiling is positive. Okay. You guys okay with this? You guys want to try one?
Yeah.
Yeah. Okay. Problem 59.
59. Okay.
59. Give it a shot. This is where identities kind of come in. We need to somehow make this either all cosines or all sine or all one thing. If it's all, if you have mixtures of trig functions, it's going to be a nightmare. Okay? So one of the things that we know about the sine square is that sine squared theta is equal to 1 minus cosine squared theta. Right? You guys remember that? Sine squared plus cosine squared is equal to 1. So what we'll do is we'll move all this stuff to one side. It's better if the square term is usually positive. So and we'll just kind of rearrange it so that everything's on the left side. So it's going to look like this. Okay. I think you guys can understand what happened. Okay. So if I move these over, they both become negative, right? And you can swap them around. Okay. So I rather put it on this side than the other side. I hate having equal on the left side. Okay, now let's take sine square and transform it into 1 minus cosine square. Okay. Then we gotta distribute the 2. We've got to combine the 2 with 3, and unfortunately cosine is negative, so we'll multiply everything by negative to make it positive again. All right, we don't want the leading coefficient to be negative, it's just annoying. Okay, so this 2 goes with this 3. Now it's -1. We don't want a negative at the front, so we multiply the entire equation both sides by -1. So now we get this. Because you got to distribute the negative, don't forget. And negative times 0 is still 0. Okay, now we're at that stage. Now we're going to go let x equal cosine of theta. If that's the case, then we get 2x squared plus 3x plus 1 equals 0. And we're going to try to find 2, 3, 1, 2. Back to back grouping. Can't pull out 2, what we're doing. Pull out the x. Can't, the only thing you can put here is a 1. So we get x plus 1 times 2x plus 1. Transform it back. Alright. X is cosine, so we change it back to cosine. So we get cosine theta plus 1 times 2 cosine theta plus 1 equals 0. And then we solve, okay? Of course, when you move the 1 over, you get this cosine equals -1. There's only one place cosine is equal to -1, that's at pi. Okay? Over here, where's cosine equal to -1/2? Well, you're gonna have a couple solutions there. Okay? But you can see that's where they're at this point. Okay? And those are the solutions, okay? I'm gonna stop here because I feel like we know what to do from there. Okay? All right, let's look at another problem. Number 9. Okay. You know, and for the AP Calc exam, you don't really need to know the really advanced forms of this. You just need to know the basics. That's all. You just need to know the basics. Because that's all they're going to really ask you. So here's another one. Cosine squared plus sine theta equals 2. It's really the same thing. I don't really feel like going through it. All right, you're going to change sine squared to cosine squared to 1 minus sine squared. And then now you have a trinomial, you're going to try to factor the trinomial. But since the denominator, the discriminant, did you guys ever learn the discriminant?
No.
Okay, you guys know the quadratic equation?
Yeah.
Doesn't sound like a very.
Okay. What's it?
Minus
What was
b.
it?
Oh,
Oh.
okay.
Alright, that's a quadratic equation, right?
Yeah.
Yeah.
Okay, the discriminant, because most of you guys don't know what discriminant is this part.
Oh.
The discriminant is b squared minus 4ac. Now, when a discriminant is negative, then you have a problem, you have complex solutions here. So here they're saying the discriminant is negative, therefore the equation has no real solutions, okay? The solution is empty. And that kind of makes sense, because if you take a number and square it and add sign to it, is it possible to get 2? That's pretty hard, okay? Because anytime this is a fraction and you square it, it actually becomes smaller. Does that make sense?
Mhm.
Let's think about this for a moment, okay? Any number that you plug in here, cosine is going to be between 0 and 1. I mean, negative 1. Okay? I can explain this another way. That's the largest cosine can ever be, right? From minus 1 to 1, right?
Yeah.
If you pick any number between negative 1 and 1 and you square it, you get a smaller number. Right? What's 1/2 square? What's 1/4? This is smaller, right? If you get what's 1/3 square? 1/9, right? It's even smaller. It's a smaller number. So if you take any number and you square it, you get a really small number, and you add it to another thing that can only be between negative 1 and 1. The only way that you ever get 2 out of that equation is if cosine is equal to 1 and sine is equal to 1 at the same time. Because if cosine is equal to 1, you square it, then you get 1, right? And if sine is equal to 1, and you add them together, you get 2, right? But how is that possible? How can you pick an angle where sine and cosine are both 1 at the same time?
Tangent.
We know that's impossible, right? If you're looking at the unit circle, that's impossible. There's no point on here where sine and cosine are both 1 at the same time, right? There is no such point, right? It's always one or the other. For instance, here cosine is 1 but sine 0. Over here, sine's 1 but cosine 0. There's no point in the circle where both are 1 at the same time. So therefore, trying to solve this equation is really silly. You're not going to find an angle that has that property, right? So that's the reason why there's no solution. That's another way you can think about it. Okay? And the whole idea is that once you go through all that work and you factor it and then you try plugging into the quadratic equation, you get a negative discriminant, it's basically telling you that you don't have a solution. That's what happens when this is negative. It means that solutions are complex, which is another whole conversation. All right, so that's the end of that. That we will save for later, and that is the end of the section, okay? So this is the last section, guys. That's point 3, and then when we come back, we will move to 8.1. 8.1, if I remember, is the beginning of the fun stuff.
Let's go.